Says, is x minus 1 a factor of 2x cubed minus 6x squared minus 12x plus 16? All right, so I'm going to do my fraction symbol, or my division symbol, and I have x minus 1 on the outside here. 2x cubed minus 6x squared minus 12x plus 16. All right, it went x cubed, x squared, x, and then x to the 0, essentially, with the 16. So I don't have to fill in any of those 0 x values. So it's already set up nice for me. Okay, I have a binomial, so I can't multiply a binomial into 2x cubed. So I have to include the 6x squared. Well, if I want to get negative 6x squared, I need a new negative 6x. So, oh, not 6x. I want it to be 2x. So when I go around, I end up with 2x cubed. And then I'll have a negative 2, this is squared. There we go. Rusty right now. All right, that should be 2x squared, so I get 2x cubed minus 2x squared. I subtract again, so do not forget we are subtracting. As I subtract, as I go down, 2x cubed minus 2x cubed goes to 0. Negative 6x squared minus negative 2x squared is what? What? Not 8. Negative 4. So negative 6 minus a negative is the same as addition. So negative 6 plus 2x squared is a minus 4x squared. So be very careful on your signs there. If you have subtracting a negative, it's actually doing addition. Bring down the negative 12x. So now I continue on. Okay, so this would be a negative 4x. As I go around, that would get me my negative 4x squared plus 4x. That goes to 0. Again, I am subtracting. So I have negative 12x, grab my x, negative 12x minus positive 4x would be regular subtraction. So that's negative 16x. Bring down the positive 16. So this has to be a negative 16. Go around, so it's a negative 16x plus 16. My same signs are what I want to happen, because then that's going to make it go to 0. So is x minus 1 a factor? Yes. Okay, this remainder of 0 tells me, yes, x minus 1 is a factor. And more specifically, I can show that 2x cubed minus 6x squared minus 12x plus 16 is equivalent to x minus 1 times 2x squared minus 4x minus 16. So using this polynomial division is factoring, essentially. It's rewriting it as a product of factors. So it's x minus 1 times 2x squared minus 4x minus 16. You will have to do this on the test tomorrow, okay? So understanding how to do polynomial division, probably the biggest thing that you want to be careful on is subtracting a negative. And then also, if you have to add in any of those 0x's or 0x squareds, make sure you see your variables go from x cubed to x squared to x all the way down. You need to see every single one written down. All right, so today we're going to do what's called synthetic division. Synthetic division simplifies the long division process. Okay, we did the heavy lifting on this yesterday. Now, synthetic division is kind of a shortcut, but it only works in specific situations. Okay, it doesn't work for all. Polynomial long division, which we did yesterday, I can divide any two polynomials. But now, synthetic division, they have to be in a particular form. If they're in a particular form, good, I can go ahead and do this a lot quicker. Must have a linear divisor. Okay, so again, this is the divisor. This was the dividend, and this was the quotient. Okay, that piece on the outside must be linear. meaning x plus 4, x minus 2, x minus a, any of them in that form. It cannot be something like x squared plus 4. That is not linear. That's a quadratic. Okay? So if we get it to be a quadratic, x squared plus 4, we have to use regular polynomial long division, which we did yesterday. But if it is a linear factor, we can use this synthetic division. All right, and we're going to focus specifically on this x minus a form, where this a is going to be a number. Okay? So our roadmap to using synthetic division. So there's a certain process we have to follow in order to use synthetic division. First step, we are going to write down only the coefficients, including zeros, of the polynomial in standard form. Okay, so I only want coefficients. So if I had 3x cubed plus 2x plus 7, my coefficients are going to be 3, 2, oops, missed one, 3, there's an x squared that's not here, so I'm going to say 3, 0, 2, 7. Again, I'm only working with those coefficients of the polynomial in standard form. All right, and this is not one number, 3027. They're separate numbers, 3, 0, 22, and 7. I'm going to omit all variables and exponents. Okay, and this is probably the biggest thing that we have to focus on when doing synthetic division. For the divisor, again, that divisor is that piece here on the outside. For the divisor, reverse the sign in front of A and put it up in the press box. I'll show you in a minute here what I mean by the press box. Reverse the sign in front of A and put it up in the press box. Okay, all right, so let's actually do one. So I want x cubed minus 14x squared plus 51x minus 54. So that is my dividend. I want to divide x plus 2 from it. Okay, so for the first step, reverse the sign of that positive 2 and put it up in the press box. So I'm going to create this little half of a square here, and I'm going to write a positive 2. That's what I call the press box. So think of it like on a football field, athletic field, the press box, somebody's sitting up there videoing the game, announcers are sitting up there, radio people, whatever. Okay, so that's the press box. I'm putting it up top. Yes, Eva. Oh, thank you. Yep. There we go. Didn't do it. Reverse the sign of positive 2, put it in the press box, so it'd be negative 2. Write the coefficients of the polynomial. And so this would be 1, negative 14, 51, and negative 54. So only writing the coefficients down. I'm not writing any of the variables down. This one was in x cubed, x squared, x, and then 54, x to the 0. We wouldn't write x to the 0 because that's equivalent to 1. So only writing the coefficients. Okay. Step 2, bring down the very first coefficient. Okay, so this one's going to be pretty straightforward. I'm going to bring this down, and I'm just going to write 1 here. Multiply the coefficient by the divisor, then add to the next coefficient. What that means is I'm going to take this and multiply here, and then it's going here. So 1 times a -2 is -2. But now with synthetic division, I add vertically. So do not get this confused with long division yesterday where we were subtracting when we move vertically. Now with synthetic division, we will add as we move vertically. So -14 plus a -2 is -16. And then I'm going to repeat the process though now with -16. I'm going to multiply here by -2, and then that's going to go into this spot. So now this would be a positive 32. 51 plus 32 is 83. And then same process, I'm not going to write with all the arrows because there's going to be too many arrows. 83 times a -2 is a -166. When I add vertically, this becomes -220. Okay, so 1, -16, 83, and -220 now are my new coefficients. All right, this original polynomial was a degree 3. It was x cubed. And I divided out one polynomial from it, which was a degree 1. So this one tells me that my new polynomial here is these numbers that I created are my coefficients. So this is 1x squared minus 16x plus 83 with a remainder of -220. Okay, so my polynomial is now a degree 2, the one that I found. So a degree 2 polynomial with my degree 1 polynomial, which was x plus 2, will give me my degree 3 polynomial, the big one we started with. Landon, do you have a question?
So I'm showing because we move one of them, take out, eliminate 1/2.
Correct. So that's why this becomes x squared minus 16x plus 83. This last spot will always be the remainder. Okay, and that might help you remember as well that that last spot is always a remainder. And then if we read from right to left, it'll go constant x, x squared, x cubed, and so on. All right, so what this is saying now is if I took x plus 2 times this new polynomial, x squared minus 16x plus 83, added on a -220, that is equivalent to my original polynomial, x cubed minus 14x squared plus 51x minus 54. So we did our polynomial division what we did yesterday, but now we did it using what's called synthetic division, where we're only focused on the numbers. And we can do it essentially all in one line. But we have to do that process where we go back up to the press box, multiply, bring it down, add. Get a new number, hit the press box, bring it down, add. And just continue that process till we get to the end. Eva, did you have a question?
I was just looking how you not, but I just factored out x plus 2, so that's why it's not x.
Correct. Okay, let's do another one. So this one's x cubed minus 57x plus 56. You don't have to write all my columns on the left. This is just a reminder of how we go through this process. Okay, so first thing, we're going to create this press box up here, reduce the sign of -7 so that becomes a +7. And now I will fill in all my coefficients. So x cubed is 1. Was not written, but we cannot forget about a 0x squared that was here that's just not written. Okay, our polynomial needs to go cubed, squared, x, constant. So this would become, in my top row after my press box, becomes 1, 0, -57, +56. Do not forget that 0 there. Okay, so first step, we're going to bring the 1 down. And then we start multiplying by our press box and continuing to add. So 1 times 7 is 7. 0 plus 7 will give me a +7. 7 times 7 is a +49. -57 plus 49 ends up being -8. So again, we're adding as we move vertically. -8 times 7 is a -56. Add those together, we get 0. So again, this is our remainder. So we have a remainder of 0. So I know x minus 7 is a factor of this. Rewriting this, this is my constant, -8. 7 would be 7x. 1 would be x squared. So I have x squared plus 7x minus 8 as a factor, and then x minus 7 as the other factor. That is equivalent to this x cubed minus 57x plus 56. If I were to multiply those through, I would get back to the same spot. So again, this simplifies the long division process, but it has to be a linear factor. X minus 7. The last one I think we had was x plus 2. It has to be in that form. It can't be x squared or x cubed or anything like that as a factor. Let's do an application problem. The polynomial x cubed plus 7x squared minus 38x plus minus 240 expresses the volume in cubic inches of a box. If the width is represented by x plus 5, what are the other dimensions of the box? How do I find volume of a box again? What do I have to do to find volume of a box? Eli? Length times width times height. So if I call this my height, we'll call this the width, and we'll call this going back the length. So when it says what are the other dimensions, it's telling me 1 is x plus 5. It's saying the width here is x plus 5. I need to figure out my height and my length. So I'm trying to essentially figure out the factors of x cubed plus 7x squared minus 38x minus 240. All right, well, I can do this using synthetic division. What am I going to put in my press box? Landon, -5. All right, and now I only fill in coefficients. 1, 7, -38, -240. Okay, right, so we should get to this point when using our synthetic division. We have 1, 2, negative 48, and 0. So this is negative 48 is my constant, 2 times x, and then 1x squared. So this is x squared. Two numbers that multiply to get negative 48 that add up to be 2. What are two numbers that can multiply to get negative 48 but add up to be 2? Jake. Negative 6 and 8. Good. Okay, so negative 6, 8. This quadratic was a coefficient of 1, and so this is the same thing as x minus 6, x plus 8. So these are my two other dimensions. It doesn't matter which way we'll go. The length is x plus 8, and the height is x minus 6. Okay, so my three dimensions would be x plus 5, x minus 6, and x plus 8. That would be final answer. But we were able to find those using synthetic division. And by knowing that x plus 5 was one of the sides, which in this case ended up being one of the factors. Okay, last thing we're going to talk about today is called the remainder theorem. Okay, and this only applies to the remainder. Okay, that's why it's called the remainder theorem. It says if you divide a polynomial p of x, so whatever your polynomial is, we're going to label it the function p of x. Okay, so p of x could be anything. P of x could be 2x cubed plus 5x minus 3 or whatever. Okay, p of x is just representing some polynomial. If you divide a polynomial of degree where n is greater than 1, so n that represents our exponent, and we'll go with degree. So it has to be a degree greater than 1, so it's not linear. By the polynomial x minus a, then the remainder will simply be p of a. Okay, thank you. All right, so this, if we simply put in a into our function, that will tell us the remainder. Okay, and that's all it tells us. So it's a remainder theorem. All it's telling us is what the remainder is. It doesn't tell us our answer when we do synthetic division, but it will tell us if we have a remainder or not, which we can use to determine if it's a factor. Because if we plug in something saying, is this a factor, we can simply put in that value into our polynomial. If we get 0, meaning our remainder is 0, yes, it is a factor. Okay? So, given the polynomial p of x is x to the 5th minus 2x cubed minus x squared plus 2, use the remainder theorem to determine what p of 3 is. So p of 3 would simply be 3 to the 5th minus 2 times 3 cubed minus 3 squared plus 2. That is going to tell us what the remainder is. When I plug all this in, I get 182. If I were to evaluate that. So my remainder theorem is telling me that this is the remainder. Okay? If p is 3, that means I was working with x minus 3. I could say x minus 3 is not a factor of this. Okay, so when it said p of 3, it's using that 3 value. Okay, standard form is x minus a. P of a would be p of 3. So right there, that's telling us x minus 3 is not a factor because we got a remainder. So if you're given a problem that says, is this a factor, you can simply use the remainder theorem, if you do it correctly, and determine if you get an answer that's not 0, it's not a factor. If you get an answer of 0, yes, it's a factor. Okay, but be careful if I ask you that on the test tomorrow and say, is this a factor? I'm probably going to add on to that and say, show me. Okay, and it's not showing me using the remainder theorem, it's showing with synthetic division or long division. Okay, but let's actually show that P3 is the remainder when you divide P of x by x minus 3. Okay, so we're going to use synthetic division. X minus 3, the opposite sign would be a positive 3. And then my coefficients, x to the 5th was 1. I did not have an x to the 4th, so that's 0. Minus 2, minus 1, and a positive 2. So let's show that this is the remainder by use synthetic division. So if I bring the 1 down, that's going to be 3. I add those together, I get 3. 3 times 3 is 9. Negative 2 plus 9, 7. 7 times 3 is 21. Minus 1 is 20. Ooh. I made a mistake. What mistake did I make? Keep going, Ava. So up here, it went negative 1x squared. X was not accounted for. I should have put a 0 in there. And then 2. So this one actually had 0, or I'm sorry, had 2 0 coefficients to it. Okay? Easy mistake to make. Make sure you are comfortable, or you're careful as you're writing these down. And maybe just do a quick double check after you write them down. Okay, did I miss any zeros in there? Are all my exponents going down? 5, 4, 3, 2, 1, 0. Landon.
Does that go back to
Potentially, there'll be 5 x's potentially, but that's not for the zeros. Okay. All right. So let's continue this on. 20 times 3, that would be 60 plus 0. So that gets me 60. 60 times 3 is 180. 180 plus 2 is 182. So that checks out up here. Yep, that is actually the remainder if I were to complete this all in synthetic division. Okay, but there will be a test question tomorrow. Well, I'll say, use the remainder theorem to show me what the remainder will be. And it's very simple. All you do is put that value into your function. Whatever answer you get, that is the remainder. You get 0, that's big, because then that tells us that it's a factor. But if you get any other number, that's fine. It just tells you what it is. Okay, I'm not asking. I mean, we could break this one down, and we can do it. Let's actually do it for practice. So this be 60 plus 20x plus 7x squared plus 3x cubed, and then plus 1x to the 4th. And this would have been x minus 3 plus 182 would have equaled my big polynomial that I started with, x to the 5th minus 2x cubed minus x squared plus 2. Those are equivalent. Okay, so the remainder theorem, again, all it tells us is the remainder. So for today, I have a worksheet that I'm going to have you work on, and I want you to do all of the problems on the worksheet. Okay, some of them go faster than